Hello friends, today in this video we are gonna discuss about the different data types in Python. So what a data type actually is? A data type is nothing but the type of the data that we assign to a variable. The type of the data that we assign to a variable becomes the data type of the variable. So for example, if you assign an integer value to a variable, then the data type of the variable becomes int. So like here we have assigned an integer value 100 to the variable x. So the type of the variable or the data type of the variable has become integer. So let's see what are the data types, what are the built-in data types that are available in Python. So Python has the following built-in data types in the following categories. So in the numeric category, there are mainly three data types: int, float, and complex. In the text category, we have string or str. In the boolean category, we have bool. In the sequence category, we have list, tuple, range. We can also include string in this sequence category, as string is also a sequence of characters and nothing else. String is nothing but a sequence of characters. So we can include string in this sequence category as well. So after that, there is a set category. We have set data type for that. In the mapping type category, we have dict data type. In the none type category, we have none. So let's discuss these categories and these data types one by one. So first of all, we have the numeric types or numbers. So there are three numeric types in Python: int, float, and complex. So int or integer, as we all know, is a whole number which can be positive or negative without decimals of unlimited length. So you can declare an integer of any length in Python. That integer can be a positive integer, that integer can be a negative integer, just as these examples show you. So as we have already discussed in our previous videos, if you want to know the type of a variable, or that is the type of data that is assigned to a variable, we have this function type. So using this function, you can determine the type of a variable. So if you just apply this type function to all these variables, var1, var2, var3, all of them will give int, because integer values are assigned to all these three variables. Okay guys, next we move to the float type. Float or floating point number is a number, positive or negative, containing one or more decimals. So we consider a number as float only when there is a decimal point in that number. Now after the decimal point, there can be any number of digits. So there can be any number of decimal digits after the decimal point. As we can see in the variable var4, we have minus 27.77777789. So the number of decimal digits after the decimal point can even be greater than this. You can have any number of digits after the decimal point when you are assigning a floating point number to a variable. So it's up to you what extent of accuracy you want, or what number of digits you want after the decimal point. It's completely up to you. So again, if we, as we have assigned floating point values to all these variables var1, var2, var3, var4, if we apply the type function to all these variables, any of these variables, then we'll get float, because the type function gives us the type of the value assigned to a variable. Next, we move on to the complex numbers. So as we all know, a complex number has mainly two parts. There is a real part and an imaginary part. Now the imaginary part is accompanied by j, and the real part is the one which is not accompanied by j. So take this example. Here we have x equal to 3 plus 5j. So this part which is accompanied by j is called the imaginary part, and this part which is not accompanied by j is called the real part. So if we apply the type function in to any of these variables, it will give us complex. So let's see some example of each of these data types. Let's flip to Jupyter Notebook and see the examples. Okay, so first we declare some integer variables. Okay, x equal to 10, x equal to minus 10, x equal to 255555, whatever length you may want to assign to the variable x, whatever integer of whatever length you may assign to the variable x. Okay, let's give them different names. Let's give the variable different names, and let's try to determine the type of each of these variables. As expected, we get the type int or integer for each of these variables. Now let's see the examples of some of floating point variables or float variables. Okay, let's assign a value of 10.2 to x minus 20.5 to y 25.999999 to z. Now again, let's try to determine the type of each of these variables. Let's run this cell, and as expected we get float for each of these variables. Now let's switch to complex types. Okay, for complex type, let's assign this value of 3 plus 5j for x. So here 3 is the real part, 5j is the imaginary part, or more specifically 5 is the imaginary part that is accompanied by j. Okay, again take another variable that will have 2j plus 15. Again let's take another variable that will only contain the imaginary part. Let's take it minus 10j. Okay, now let's try to print the type of each of these variables like before. Okay, now we run the cell and we get complex for each of these variables as expected. Now let's see an interesting thing. From this variable, how can you extract the real part and imaginary part? So Python offers you a property or an attribute called a real and another attribute called imag to determine the real part and imaginary part of a complex variable. So let's try this out. Okay, run it. We get 3.0 or 3, which is the real part of the variable x. Now try to print the imaginary part. Of x. So here also we get the correct value, that is 5.0 or 5 for the imaginary part. So if we apply the same thing for the rest of the variables, then also we can easily determine the real part and imaginary part of each of them. Now let's try to determine the real and imaginary part of this variable z, as this variable does not have any real part. So let's see what it prints. Okay, so z dot real obviously gives us a real part. And z dot imaginary gives us the imaginary part. Now let's try to print both of them, and we get minus 0.0 and minus 10.0. Now you may ask me, we don't have the real part, so the value is 0.0, that is fine, but why the minus sign in front of it? So you might ask me the question. The answer to this question is this: when we don't have either of this part, when we don't have either the real part or the imaginary part, then the other part that is available, the sign or the symbol of that part turns out to be the sign of the part that is missing. So here we had the imaginary part and the sign of the imaginary part was minus. So the sign of the real part, even if it is 0, it will also be minus. So that's the answer to this question. So guys, I think you have understood that. Now to verify that, let's take another variable k, and now we will have only the imaginary part, but the sign of the imaginary part will be positive. So it is plus 10. For the imaginary part, we have plus 10. Now again, try to print the real part and the imaginary part of the variable k, and let's see what happens. Okay guys, now you can verify that for the imaginary part, as we had a positive number, for the imaginary part we had the number 10 or plus 10. So for the real part which was missing, the real part is 0, but there is no minus sign in front of it, as the imaginary part which was available was positive. That's why the sign of the real part that was missing, that also turns out to be positive. So that's the answer to that question. The part that is missing will have the same sign as the part that is available. That's it. So friends, that's it for this video. You can let me know your feedback about this video in the comment section, and if you have liked my video, please subscribe to my channel and please hit the bell icon so that you get notified when I'll upload more Python and data science related videos. And please don't forget to like and share my video so that it reaches a larger audience and they also get benefited from it. Thanks a lot for watching.